Yesterday, I told you that the objective of this session is going to be, to understand the challenges with traditional wide area network. So I'll open up a topology, by the way, and using that topology, we will try to understand the real problem. So let me stop all these nodes and I'll open up this topology here. So imagine, in this topology, you see that I have mentioned the service provider as ISP, but that could be in most cases, that could be MPLS. So I'll do one thing. So let's assume this is your MPLS provider 1 and this is MPLS provider 2. And usually you would have a connection from ISP inside DC 1 as well as you would have a connection from another ISP or maybe from same ISP in other data center. And for redundancy purposes, you may have multiple internet connections as well. So the number of internet circuit will be depending upon the type of redundancy that you want. And this is kind of traditional way of doing traditional WAN. Like in most cases, you would use MPLS. Yeah, I mean, there will be some customers who are not using MPLS and instead they would like to use internet. And then on top of internet, you would be building up the IPsec tunnel or maybe, DMVPN. So that depends again. But in most cases, you would see that people are using MPLS. So let's assume that this is one of the bank ABC. So they have got DC1 and they also have got DC2. Now they have got MPLS connections, like there are dual MPLS connections in each data center. And then you have got remote sites. So you could see that we have branch 1, then we have got branch 2, we have got the branch 3. I'll talk about the challenges. And there are many challenges that I can outline. But let's try to pick them up one by one. First of all, imagine that across all remote sites and data centers, so you have got, let's say, 100 routers. And I'm talking about the WAN Edge routers only. WAN facing routers. I'm not talking about the internal routers. Like in data centers, you can see that we have got WAN Edge routers. Behind those WAN Edge routers, also we have some other routers in place. Imagine that across all these 100 routers, you wanted to change the DNS IP, just DNS IP address. So maybe DNS IP got changed and you need to update this DNS IP all across your 100 routers. And it's not about DNS. Sometimes you may have to change just NTP. Sometimes you may have to change a syslog, maybe SNMP community. These are very small changes. So let me ask you this question, Ankur, if your microphone is working today. Can you tell me if you have to change or you needed to change any of the one thing which I have listed? That's very simple change, right? If you wanted to change your community, you wanted to change NTP server IP, or you wanted to change the DNS server IP, it's a very simple change, straightforward. How do you do it across all 100 routers?
Yeah, so over 100 routers, if we don't have, I mean, if we are just doing by CLI, it's a pretty long change. Like we have to, it might be as like a 2 3 commands only, but we have to log into each switch and then apply it.
So you have to log into each router, right? So if you have got 100 routers, then you will have to log into 100 routers. And not only that, but also I hope that you must have heard about the pre-check and then post-check, right? So you have to follow the change process. And if you are following that change process, you will have to perform pre-checks and post-checks. And if you are performing pre-checks and post-checks, so let's assume that including pre-checks, post-checks, taking backup, pre-backup, post-backup, everything, and then making all these changes. One router is consuming, let's assume, we can assume maybe 10 minutes or maybe 20 minutes, not 10 minutes, but let's assume it 20 minutes. So one router is taking about 20 minutes. So how much time do you think that, it will take for 100 routers? So that is about, if one is taking 20 minutes, so that means that it will take about 20, sorry, not 20, but 2000 minutes. Now, how many hours it makes? Around 33, or you can assume it like 35 hours. Now, one engineer works for about 8 hours in a day. If you have got only one engineer, so it will take about 3 to 4 days. If you have got two engineers, it will take maybe 2 days. If you have got 4 engineers, it will take 1 day, kind of thing, right? Whole day. But do you think that if you even if you had let's say 3 to 4 engineers, let's say you had 4 engineers, but do you think that you would be able to utilize all of them for same task? Maybe You have some other things which are going on in parallel. So you cannot engage each and every one on performing same thing, right? So I mean, that was a challenge actually. For me, it is a challenge. One, why is it a challenge? One, it is a time consuming process. Second, it is also utilizing a lot of my resources. So cost is higher, absolutely, and the process is really slower, is very slower. So that's one challenge that I have described to you. That's one of the challenge. Now I'll talk about the second challenge. Imagine this is MPLS that is from Tata in India, and this is another MPLS which is from Airtel. So there are two ISPs, not ISP, but MPLS provider, I would call them, for all your remote branches, because you are using BGP there in between PE and CE. So this is your PE and this is your CE. So you're using BGP everywhere. You're running BGP. And that way you have got 100 branches. So for all 100 branches, let's say Tata is primary, whereas Airtel is secondary. So you have configured BGP in a way so that you are using Tata as primary MPLS provider. So whenever any branch office is trying to reach any of the data center, so they are using Tata. They're using Tata MPLS to reach data center. In fact, when returning traffic is coming back, that is also coming back from DC to Tata MPLS and then your remote sites. Why? Because Tata is primary MPLS provider. So generally, and now even over here, you could define the primary data center and secondary data center. So you could advertise the default route from primary data center with some different BGP attributes and secondary data center. From secondary data center also, you could advertise a BGP default route with different BGP path attributes. That way, Tata is always preferred over a Airtel. So in short, all the branches are reaching out to data center via Tata. That is my primary MPLS. Tomorrow, if management takes a decision, or maybe you have to test, you have to perform the DR test, disaster recovery test, right? So now you will have to ensure that for all your branches, your Airtel is primary. So to make it primary, what will you do now? Tell me. If you have got 100 branches, like obviously in this example, you could see that there are only 3 branch offices, but assume that you have got 100 branches and across all 100 branches, your primary MPLS provider is Tata and Airtel is secondary, but you need to change it. Maybe you are doing some DR testing, or maybe management has taken some decision and management wanted you to select your Airtel as a primary MPLS provider. What will you do to accommodate to achieve that task now? Arun, you tell me. What will you do? And I have already told you, like BGP is running there in between PE and CE. Arun Sarvaran, I hope that you can hear me. Chetan, I still can't hear you, so it seems like your microphone is not working. Mahesh, can you explain that how we can really accommodate?
We can make the primary for the Airtel.
Yeah, you need to make Airtel as primary
Yep.
MPLS. So basically, you have to play around the BGP path attributes, correct? So if you are playing around the BGP path attributes, then for outbound traffic, obviously you could use the local preference, and for inbound traffic, you could use the AS path attribute. That's the only solution that we have got here, right? I mean, you could also use some other attributes, but those are the most safest, I would say, attributes among all when it comes to BGP. Like for outbound traffic, use local preference, and for inbound traffic, use AS path attribute. Don't you think that you will have to go to each and every branch router and will have to make the necessary changes into BGP? And again, imagine that how much time it will take to go to all 100 branches, and maybe some of them are single CPE and some of them are dual CPE. So you'd have a lot of routers, maybe 150, including all 100 branches. So you have to go to each and every branch router and you will have to make all these changes manually, which is again time consuming process. And you will you will have to follow the change process like pre-checkups, post checks, and all that. That's a time consuming process again. That is slowing down my change implementation. I mean, that's not in today's world, especially where you're using containers, Dockers to deploy your VMs, and you're doing it so quickly. So you are getting your infra ready. You're getting your applications ready quicker than ever, right? Nowadays, your physical infrastructure like this, right, is not coming up quickly as it should have, right? So I gave you this example again where you wanted to change your primary MPLS provider. So it's very difficult job. It's very difficult job. You will have to ensure that you go to each branch router and then you play around the BGP path attribute. And you will have to do it again individually for all branch routers.
Hello.
Yep.
Yeah, hi. My question is, apart from these config changes, means is there any another features? Means I hope some feature would be there, but I just wanted to know, like SE and
What feature?
we have discussed two scenario regarding this config changes.
No, I mean, I'm coming up. I told you, like, there are many use
Okay.
cases. There are
Okay.
many things that I can describe to you.
Okay.
Many. But I'm
Okay.
not going to describe everything. My objective is to tell you that why software-defined networking was important for us.
Okay.
So this is another scenario where, there was a lot of delay, right? And time-consuming process again. Next, I could ask you another problem that we had previously. Imagine that there is a branch 3 router. It's a remote branch. And you made some changes in its ACL. And then after you lost your remote access. Why? Because that ACL was applied maybe in its control plane policy, or maybe on interface. But as a result, maybe you were sitting in headquarters. So from headquarters, you lost remote access to your branch router. How would you fix that problem then?
So in this case, FE should be available at that customer sites, which remote went down.
Not went down. I said maybe, you lost access to remote access completely. So even if one of the WAN link was working, and I gave you this kind of example, maybe you modified the ACL. It's not about the WAN link went down. So WAN connections are up, but somehow you cannot access this router from a remote location.
Yes, so FE should be available to provide the remote access to that headquarters engineer. Whatever.
FE is not available immediately. Maybe it will take another 2 days for FE to reach that remote location. You're not always going to have FE immediately. You just
Yes,
say FE is available. It's not possible. Sometimes it takes like a week to arrange the FE. So that's another challenge that we had before.
yes.
Okay. Now that was challenge number 3. The next challenge number 4 is, let's assume that you know that you are going to roll out a new branch. So generally, how would you prepare? Like, I'm asking you. So let's say this is the scenario. You have got 2 MPLS providers. One of them is primary. The other one is secondary. And you need to roll out this new branch 3. How would you roll it out? Like, what will you do in order to roll out a new branch? How would you prepare for it? So you need to order this hardware. Now, probably you would ask your vendor to ship hardware in HQ, maybe. And in HQ, you would make some sort of configuration onto that router. And you would ship that router back to its original branch with FE, field engineer. And that field engineer would be responsible to make all the cable connections and power connections. And after booting, after doing power on, if remote connectivity does not restore, then you will have to ask your field engineer to share the screen. And to do so, field engineer will have to arrange the internet connectivity on his or her local laptop or desktop, whatever they are carrying there, right? They will have to ensure that they have the internet connectivity. Then only they can provide the remote access to us, because we are sitting in headquarters. So it was very difficult to troubleshoot at that point in time. It was difficult to roll out a new branch. I know in most cases you would not face problems, but if you face problems, then it is very difficult to fix it without having a knowledgeable FE. So your FE should be enough knowledgeable so that if you are telling him or her over the call anything, you're explaining anything, at least they can follow, or maybe they share the screen. So that type of field engineer you need. So that was another challenge. Now, the other challenge was, since these are MPLS connections here. So if there is a end user machine or lane user in one of the remote branch, and that lane user wants to have access to the internet, obviously, if they are going to access any enterprise application which is hosted in one of their data center, they have to come through the MPLS. But even if they want to access internet, since they are getting backhauled into data center, so even for internet, every user is going to backhaul into data center, and from DC probably you would go to ISP, and similarly your traffic would come back. So even you are consuming this MPLS bandwidth for internet connectivity. And slowly what happened was that internet based applications became heavier and heavier and heavier. Like every day, internet applications are becoming more heavier, and that would require more bandwidth. So don't you think that you should increase the MPLS bandwidth in just in case if you want to provide a good internet connectivity for your lane users? If you want to reduce the latency, then don't you think that you will have to increase the MPLS bandwidth for each branch over the time? Like I've seen where a few banks were using like 128 kbps of MPLS connection. I imagine if they have to provide the internet connectivity for their bank users, would it be possible for them to access the internet? Yes, they can access the internet, but it will be very slow. And in fact, even with 128 kbps, your Teams will not work. Your Office 365 will obviously have lots of challenges. Lots of challenges. Even if you change it to 256 kbps, still you would have challenges. So you will have to purchase MPLS link, maybe, like 6 meg or 10 meg. Generally, you would go for 10 meg. Maybe over the time you would go for 20 meg. But the problem is that as you ask your provider to increase the bandwidth, MPLS bandwidth, the cost would keep increasing. At one point in time, you would start thinking that probably you're not getting ROI, return on investment, because you are investing money for increasing the bandwidth, and probably your branch is not making that much money. And now you do not have any other solution because that's the only connection that you have got in the branch office. Now, if you want that there should be a direct internet connection, let's assume that you said, okay, let's have a direct internet connectivity in branch. But the problem is that now you have to provide the firewall and proxy services at the branch level. So overall cost, infrastructure cost would get increased now. Why? Because you have to purchase a separate firewall and probably a separate proxy for each branch if we are providing a direct internet connectivity. And then yes, overall latency for internet will be decreased. But now the infrastructure cost is very high, because not only you are buying a separate firewall for each branch, but also you are buying a kind of separate proxy. I'm talking about the forward proxy, like secure internet gateway type of service. So that is a problem. And on top of it, if you talk about the MPLS, MPLS does not encrypt data. You must be knowing about it, that MPLS does not encrypt data. Now, if you want to encrypt your data, because at the end of the day, your traffic, like branch is sending traffic over to data center using MPLS, then your data is going to travel in plain text format. If you don't want to take risk, what will you do then? How would you fix that problem? So over MPLS, you would have to enable the IPsec tunnel. In most cases, you would be using DMVPN, where the IPsec tunnels can come up dynamically. But again, the configuration is very complex through the CLI, is very complex. At the same time, the troubleshooting is complex. Now, let's talk about the load balancing in the branches. Earlier, like traditionally, we performed load balancing based on layer 3 subnets, based on layer 3. Like for some of subnets, maybe MPLS provided to Airtel is best. For some of prefixes, Tata is best. But you cannot say that, okay, for this application, traffic should go via this circuit or that circuit. You cannot say that. Why? Because you had limited application awareness. You had what? Limited application awareness on your routers. So application awareness was not available. Then slowly, firewall started this feature. They added this feature on their firewalls, like different OEMs added this feature on their firewalls where you could match your data using applications. Also, we could take the decision based on application data. And that is what we call here application aware routing in SD-WAN, application aware routing, AAR. So basically, in short, now routers are having the application awareness. And we can tell our routers that, okay, for this application, use this circuit or that circuit. So application-based load balancing is possible. Earlier, it was not possible. These all are the challenges that I'm talking about. Now, the only solution that we have got for all these problems which I have described, as I told you, there are many use cases, many of them, but I cannot explain you each and everything or each and every use case that why SDN was launched. So then people started thinking about the SDN basically. So first of all, let's talk about the SDN, software defined networking. In SDN, basically what happens is we kind of would have a centralized controller And from that centralized controller, we are going to manage all our routers. So if you want to make any configuration changes, that's across all branches, it's easier for you to make those changes from that centralized controller. You could create your controller by your own. And in fact, in the beginning, we had so many controllers from third party for automation. I'm not sure that if you have heard about the AlgoSec. I'm now talking about 2012 or 2013. At that point in time, AlgoSec launched their own tool that was helping you to automate your configuration, where you could make the configuration across your network from a centralized location. So they had that kind of controller. So basically, third parties were working on creating those type of controllers. And in fact, then using scripts, we could also create our own controllers, like either using bash script or maybe using Python. We can create these scripts and we can push changes from a centralized location. But that is also an example of the SDN, software defined networking. So either you define your controller, you create your controller. If you know the coding, you create your controller by your own, or you purchase the controller from third party. And but slowly then, Cisco, Juniper, all these big giants, they started working on this kind of automation, and they kind of introduced their own controllers. And when it comes to software defined networking within Cisco, as I told you even before, that we have got like three different solutions. One is obviously SD-WAN to manage your WAN edge routers. So this SD-WAN will be used to manage only WAN edge routers. Then you have got SDA to manage your LAN, local area network. So in LAN, you have got wired and wireless both. Wireless and wired, both type of network can be managed through the SDA. So in SDA, basically the controller name is called Catalyst Center. And then you have got ACI for data center, for Nexus switches. So you have got Epic controller for Nexus switches. So Cisco currently has like three different solutions, and it's a end-to-end SDN based solution. They also call it end-to-end SDN based solution. Why do they call it end-to-end SDN based solution? Because in local area network across all branches, whether it is wired or wireless, in local area network, you can use the SDA. Then to manage all your WAN facing routers across data centers and branches, you can use SD-WAN. So SD-WAN would provide connectivity from your branch to DC or from branch to branch, like that. And then within data center, you would have Nexus switches, and to manage those Nexus switches, we can use the ACI. So it's an end-to-end SDN based solution, and that's what Cisco calls it, that we are providing end-to-end SDN based solution. So here, as part of this training, our focus will be around SD-WAN only, which means we would learn that how to manage your routers, WAN facing routers, only WAN facing routers, or you can also call them WAN edge routers. So we are going to manage all our WAN edge routers using a centralized controller. So we will talk about those controllers. We will talk about that, how SD-WAN works and all that kind of stuff. So we have spoken about challenges that we kind of faced during with traditional WAN connectivity. I gave you a lot of examples, and that is why now we are using what? SD-WAN. And SD-WAN would provide you the solution for all the problems that I have described, that I have discussed with you. And slowly and gradually you would get that. You would understand that yes, SD-WAN is helping us to overcome with all those problems that I have already described to you all. So that's that. Anyways, now I'll open up the PPTs, and I would like to kind of give you an example using PPTs also. So this is kind of traditional WAN. Like if you wanted to interconnect two branches, generally you would have MPLS connection there like this, or Metro Ethernet connection. And for a backup, you would have internet connectivity, and on top of that, you would build IPsec tunnel. Then each router would have its local management plane, local control plane, local data plane. And this is what I have already discussed with you. Management plane was local, and therefore we needed to go to each router individually in case of, if we required to make certain changes across your branch routers. Why? Because each router had its own management plane, and each router had its local control plane. Therefore, we needed, like if we wanted to change anything in routing table, then we needed to go to each and every router to make the necessary routing changes in order to achieve your targets. This is kind of traditional way. But now things are changing. And why things are changing? Because now users have got more requirements. More and more applications are moving into cloud from on-prem. And if those applications are moving into cloud, which means in in most cases, you would have access to those applications using internet. So you need more bandwidth. Software as service, that we are providing nowadays, and you can take an example of Office 365 as well. That is the exact example for the SaaS-based application, software as service-based application. Then infrastructure as service is, I hope that some of you might have heard about it. When you build your infra inside AWS environment or maybe inside Azure environment. So you can also build your infrastructure inside Azure cloud or maybe AWS cloud. So that is called infrastructure as service. Now, it is important for branches to have the direct internet access, but then there will be other concerns as well, like security concerns. And that is why SASE solution comes into the play. Zscaler type of thing, Cisco Umbrella is there. Then from Palo Alto, you have got Prisma access. If you don't want to purchase a separate hardware for each. And nowadays, this is what we want. We want to access application at any time and from anywhere. Like even if I'm at home, I still want to have access to my corporate applications, not just when I'm in office. Yes, there are customers which you can find where, you would have limitations to access their applications only from their local machines, which are installed in their offices only. So they still do not allow you to access their applications from remote location. So, different customers would have different mindsets and different expectations from their network. But anyways, this is the new infrastructure where you still have the on-prem data centers. You have got a concept of multi-cloud, like maybe some of your applications are hosted in AWS cloud, some of applications are hosted in Azure cloud. Then you are also using SaaS, software as service. You're also using infrastructure as service. And earlier we used to dependent over MPLS. Traditionally, we used to rely over MPLS only. But nowadays we are also providing internet connectivity directly to our branch offices. So we will have to ensure that they get secure internet connectivity in branches. Not only that, but there will be some locations where, physical internet connectivity is impossible. And therefore, you are relying over the 4G or LTE.
So you are talking about the branch side getting direct internet access. Is there any security available in SD-WAN?
So yeah, in Cisco, we have that kind of capability as well. That router itself can provide you sort of security features. But as I told you, like SASE is also another option, right? Where you could take your user traffic to the cloud-based proxy, cloud-based firewall like Cisco Umbrella or Zscaler.
Okay, so we need to integrate those things with the SD-WAN.
Correct. So now these are the challenges. Obviously, we have already spoken about it. Security challenges are there. Limited app awareness, no cloud app readiness. Like if I want to tell my router that, hey, for Office 365, use this circuit, use Tata or use Airtel. Can I do that? Of course, no. Higher cost. I told you, you need more resources, you need more bandwidth, you need more hardware, you need more licenses, and of course, you need more support contracts as well. So as a result, cost will be higher. Complex operations, obviously, and then insufficient bandwidth. Because for how long you would keep increasing the bandwidth? At some point in time, you would understand that you're not getting ROI. So you would stop increasing the MPLS bandwidth across the branches. So it was complex to operate, difficult to secure. Like I told you, like if you wanted to secure the connectivity between branch and the headquarters and data centers, you could achieve that by setting up the IPsec tunnels or maybe by implementing DMVPN. But it was very difficult. And then as a result, still you would get the poor user experience. Now, the only solution that you have got for all these problems is to use the SDN, software defined networking. And then I told you that within Cisco, let me see if I really have that option over here. No, I don't have that. That slide here, which dictates that within Cisco SDN, we have got like 3 different solutions: SD-WAN, SD Access, and then ACI. So that slide is not available. By the way, with SDN, obviously software-defined networking, you would have a controller-based networking. Like you would have a centralized controller, and from where you are going to manage all your devices. So that's that. Anyways, now this is Cisco SD-WAN, and I told you that earlier it was a Viptela SD-WAN. In 2017, Cisco acquired Viptela. And that is why those names are still starting with V, Although in recent times, Cisco has already changed or renamed all these terminologies. So we manage starting with V, vSmart is starting with V, and vBond is also starting with V. So these all are the control components. So if you look at here, Cisco doesn't have a single controller. Like generally you would, if you look at Velo Cloud, if you look at Silver Peak, they have got a single control component and they do everything from that single control component, like orchestration, control plane, management plane. Everything is done by a single component. But when it comes to Cisco SD-WAN, Cisco is using a distributed architecture when it comes to its control plane, when it comes to its management plane, when it comes to its orchestration plane. So they are using distributed architecture. So they have got different components like vManage, vSmart, vBond for different capabilities, for different roles. Like vSmart is your control plane. So you have a centralized control plane, but for that we have dedicated components called vSmart. Then we have got vManage that works as a management plane. Like you are going to have access to the vManage using GUI, and you would be managing all your infrastructure from the vManage only. So that is your management plane. And vBond will be used as an orchestrator. Like for an example, if you want your branch routers or branch sites to talk to your control components, first they will start with vBond. That is why we call it orchestrator. So for orchestration, we have got a different component. So in short, I would say that in Cisco SD-WAN, we are not depending only on a single control component. Instead, Cisco is using a different approach. They are using a distributed architecture where we have got different control components for different roles. So that's the major difference in between the Cisco SD-WAN and the other SD-WAN providers. Like if you take an example of Silver Peak or Velo Cloud, or maybe if you take an example of Prisma SD-WAN, they all have got a single control plane, single component working as a management plane as well as orchestration plane. But in Cisco, they are using distributed architecture. Although there are some other vendors as well who are also using the distributed architecture, and that is Versa, one of them. That is where Versa comes into play, right? So Versa is also using a kind of same approach as Cisco, where they also have kind of distributed architecture when it comes to their control components. But anyways, in Cisco, we are having all these control components like vManage, vSmart. vAnalytics is also there, but that is only for monitoring purposes, that is only for monitoring purpose. And then in data plane, you are still, we were already using routers and we are still going to use routers. So routers are not going away. Routers are not going away. Always keep that in your mind that routers are not going away. In branches, we used to have routers. We are still going to have the router. Data centers, we used to have routers, WAN facing routers. We are still going to have the WAN facing router. So you're not replacing routers with software. Routers will still remain there. So those are your managed routers. But the good news is that earlier we used to rely on MPLS for interconnecting your branch to campus, data center, and all that kind of thing. But now not only you can use MPLS, obviously that option is always there, but also you can utilize your broadband internet connectivity or maybe internet lease line. Also, you can leverage your 4G, 5G, LTE network. That is also possible. And using them, you can interconnect your branches to campus or data center or with the cloud. And you see that here, the connection between routers is basically, there's a symbol that, lock button is there, right? Why? Because it is a secure connection. So in Cisco SD-WAN, a connection between routers will always be a secure connection, which means it will always be a IPsec tunnel. So if you are sending any data from one branch to another branch or from branch to campus, from branch to headquarters or data center, wherever, your data will always travel safely. Your data will always travel securely. Why? Because IPsec tunnels will be coming up between the routers automatically. If anybody has got any questions so far. So Cisco SD-WAN is nothing but it represents the shift from older hardware-based model of legacy WAN to secure, software-based virtual IP fabric. So it will also create a fabric. Fabric is nothing but it is a virtual network that runs on over the standard network transport services. So we are not asking you to change your transport services. If you want to use MPLS, keep using MPLS. If you want to use Metro Ethernet, keep using Metro Ethernet. If you want to use broadband internet connection, keep using broadband. So it's up to you.
So basically, this is providing ease of management and control as compared to the legacy ones.
That is correct. Also, it is adding the transport services as well. Like earlier, we were heavily dependent over MPLS, but now we can also use the internet. And I'm not talking about the internet lease line. In fact, you can use a normal broadband connection.
Broadband or these 4G, 5G services for transport we could use. The legacy also using DMVP and IPsec, correct?
Yeah, but to build the IPsec tunnels between the remote sites, you needed kind of public IPs and all that kind of stuff. Even for DMVP and not for branch, but for hub locations, you needed to have the static IPs and all that kind of. But that
Yeah,
kind of
the hub.
requirement you do not have anymore in SD-WAN.
In the hub, there is always a static IP requirement.
That's what I told you. At least at hub locations, you would require the static IPs. But even that requirement does not exist here in SD-WAN. So in that essence, it's a little different than DMVPN and all that. And also for DMVPN, you needed to make the configuration changes across multiple branches. The troubleshooting was very difficult. But here in SD-WAN, all these IPsec tunnels between branches will be coming up automatically without making a single change. You don't require to make any changes there.
So ease of management control, right?
Yes. Ease of management, troubleshooting, making configuration changes. Alex, you were saying something?
Yeah, just to see what I understand it. So what you said is what we're doing is basically removing the management control, data control, and decoupling all those controllers from the hardware and moving to a centralized location where you're managing all those controllers where they are independent of the hardware.
That is correct. So earlier what was happening was, like, if I take you back to my couple of slides here, so I displayed this example. If you look at here, we have a local management plane for each router. That's the traditional WAN. But now, instead of having a local management on each router, what you are doing is that you are going to have a centralized management over here, like we manage, right? Which will provide you a centralized management. From there, you can manage now all of your routers. Make sense?
Yeah, and this centralized infrastructure can be on-premise and cloud. Or
And
this is
control.
specific.
Yeah, that's correct, Alex. And also you have got separate centralized control plane. And you know what? How it is going to help you basically having a centralized control plane. This is your centralized control plane. So basically, if you have to tell all your branches, let's say you have got 100 branches. So you just have to tell your control plane that for all these 100 branches, make Airtel or AT&T or BT as primary and Orange as secondary, or maybe whichever ISP you have got there. So it's super easy for you to make those type of changes by having a centralized control plane. Earlier, if you had branches, then you needed to go to each branch router and make your changes locally because each router had its local control plane. Make sense? And it says that virtual IP fabric. So the meaning of that is that your routers, like here, if you look at the campus, data center, cloud, branch, colo, you have got routers installed everywhere. In cloud, obviously you would have a virtual router, but one thing would be common, maybe internet. Internet is available everywhere. So you got the internet connectivity in cloud, internet connectivity in data center, internet connectivity in campus, internet connectivity across all branches, internet connectivity across all the co-locations. Now, on top of the internet, it will build a virtual IP fabric overlay automatically. So underlay is your internet, and in overlay, it will create a virtual IP fabric, which means the IPsec tunnels will be coming up between the routers over the internet automatically. And that's called virtual IP fabric. And that happens automatically, by the way. You don't do anything for that. So as a transport, you can still rely on MPLS if you want to keep using MPLS, you can keep using MPLS, but also you can use internet, and mainly you can rely on the broadband services, and also you can rely on 4G LTE services. So transport is same as before.
Sir, this vManage and vSmart and vBond, this all will be installed, or any hardware is there, or is like a software where we want to install in our data center or somewhere?
That we will be covering, Pankaj, because I still have to cover each and every component individually, and that is very next topic, So let me tell you the benefits of Cisco SD-WAN. I'll come back to, to your topic, like whether vManage is a hardware or not. So if you want my short answer, so mostly those are virtual, but at least one of them could be hardware when it comes to the control components. Okay. Anyways, routers in Cisco SD-WAN. Routers can be physical, can be virtual. Why do you need virtual routers? Because if you have got a cloud where you have built your infrastructure as service inside AWS public cloud or Azure cloud, then you cannot have your hardware router. You cannot install your physical router there. That's impossible. That is impossible. So therefore, you need a virtual router to be installed. So as a virtual machine, you can install your router inside cloud. So that is why you required virtual router. Now I told you that your management can be on-prem, can be on cloud, which means that vManage can be installed on your ESXi, and also you can install it inside AWS or maybe Azure. But always keep in your mind that your vManage, your management plane will always be a virtual machine. Always. Like you cannot ask Cisco to ship a hardware vManage. That is not available. So you will have to arrange the hardware resources by your own, either on-prem or maybe inside cloud. And then on top of that, you can install the virtual vManage. Now, zero-touch provisioning in minutes deployment with zero-touch provisioning. So that is very useful, especially for the branches. Like if you are onboarding a new branch, so generally you would ask to make the configuration on your routers, on branch routers using FE, field engineer. Like mostly you would ask your field engineer to make those changes. But with SD-WAN, all you need to ask your FE to make the cable connections and power on the box. That's it. Ask your FE to unbox your router, to place it in rack, make the cable connections and leave it. Rest can be done automatically, and that is called zero-touch deployment, zero-touch provisioning, where you do not require any field engineer to make the changes on your behalf on your router by taking its console access. You don't need that. Okay. If you cannot have your router to obtain an IP address on its WAN facing interface using DHCP, like DHCP services are not running there, then you cannot perform this GTP. Then at least you would require field engineer to take the console of your router and configure that IP address on WAN facing interfaces. But if you have DHCP services running out there, then obviously you can perform zero-touch provisioning. So to perform zero-touch provisioning, obviously there are certain requirements, but my point is that this is doable in SD-WAN, where you do not ask your field engineer to make any single change on your router. Just power it on and leave it. Now, the question is that how it works, that obviously we will cover in much more details in future. So for GTP, we have got some dependencies. Okay. Then obviously we have done the separation of management plane, control plane, and data plane for scaling. So you have got a separate management plane now, a separate control plane, and separate data plane. So in data plane, you still have got your routers, but then you have got a centralized control plane and also centralized management plane. So you have offloaded your routers from certain tasks, and therefore the performance of the routers would scale up, will not scale down, will scale up. Okay. Now in SD-WAN, having choice of topology is super easy. Like you can convert your topology from hub and spoke to full mesh, from full mesh to hub and spoke, or maybe to a partial mesh. It's a matter of point and click. Flexible connectivity with any WAN technology. I told you in the beginning that for SD-WAN, we do not require you to have a specific type of transport. You can still rely on your existing transport like MPLS, or maybe you can simply rely on broadband connectivity, internet connection. You can rely over metro Ethernet connections. You can rely over satellite connections. You can rely over 4G, LTE type of connectivity. So you can use any transport. And that's the kind of flexibility you get with SD-WAN. So you don't rely on a specific type of transport. Secure segmentation support. I told you in the beginning that in SD-WAN, we can have VRFs created. Although in SD-WAN, we call it VPN. We don't call it VRF anymore. We call it VPN. But on Cisco routers, the VRFs will be created. If you are using Viptela operating system, then they create VPN. They call it VPN. But it's the same thing. So for segmentation, you would use the VRF. So for an example, in your environment, you have got corporate users, you have got guest users, and then you have got the IoT devices. Then you have got some maybe HIPAA compliant devices, machines. So you need to have like a separate network, different network for each different types of users. So for corporate user, you need a separate network. For guest users, you need a separate network. For IoT, you need a separate network. And for HIPAA compliant machines, you need a separate network. Like generally hospitals will have to follow that compliance, where they keep, their patients' information. So they have to follow that HIPAA compliance. So for those machines, you would have to use a separate network. Now, would you use a different hardware for each one of them? No. In Cisco SD-WAN, what you can do, you can create VPNs/VRF. also known as VRF. Like maybe VRF A, or in Cisco SD-WAN, we cannot create the VPNs or VRF using names. We cannot use alphabets, but we can use numeric numbers. Like we can have a VRF 10 for corporate users, VRF 20 for guest users, VRF 30 for IoT devices, VRF 40 for HIPAA compliant devices, HIPAA compliant network. So we can have different VRFs for different type of network. And you know what? You must be knowing, you must remember that by default, your routes doesn't go from one VRF to another VRF. And therefore, your data will also not be going from one VRF to another VRF. However, inter-VPN communication is possible. Inter-VRF communication is possible, but you would have to perform route leaking. You will have to leak your routes from one VRF to another VRF. But point is, secure segmentation is achieved by the help of creating multiple VRFs. Then single pane of glass, like complete visibility from single pane of glass, and that is because of the vManage. So you would look at your entire wide area network from a single pane of glass. Like from vManage, I can get to know that which site is up, which site is down, which all routers are up, down, how they are behaving. So I would have a complete visibility. So I can also make the changes. I can monitor, I can make configuration changes, I can validate configuration, I can do troubleshooting from a single pane of glass, and that is vManage. Now, in Cisco SD-WAN, you also have a feature called application-aware routing. Like you can go to your routers and tell them, hey, for YouTube, use Internet Circuit 1. For Facebook, use Internet Circuit 2. For Office 365, use Internet Circuit 1. Like that. So your routers are application-aware routers, and therefore they can perform application-aware routing. Then you have a secure control plane and data plane connectivity. So basically, you need to understand the data plane connectivity and control plane connectivity. So if your router is making a connection with vSmart, or making a connection with vManage, or making a connection with vBond, that is kind of a control connection that we call as a control connection. But when a router makes a connection with another router, that is called data plane connection, which is an IPsec tunnel. So all those connections are secure connections, whether it is an IPsec tunnel between routers or control connections between control components itself or between routers and control components. All of them are secure. So for control connections, we use DTLS, whereas for data plane connectivity, we use IPsec tunnel. And you know what? You don't do any configuration manually. You don't tell your router that, okay, in data plane, use IPsec, for control connections, use DTLS. You don't have to tell it. Your routers, your control components are enough capable to identify, to understand where they have to use DTLS and where they have to use IPsec. But it's all secure. So all the connections are going to be a secure connection. Cloud readiness. So you can integrate your SD-WAN with SaaS-based applications like with Office 365, with Box, with Dropbox, Salesforce, etc., etc. Also, you can integrate your SD-WAN with infrastructure as service. Like you have an option to deploy the virtual router. That option is always there. For overlay routing, they have got a Cisco proprietary protocol, and that is called Overlay Management Protocol, OMP. So OMP stands for Overlay Management Protocol. So that's a Cisco proprietary protocol that will be used for enhanced routing functionalities with overlay routing. So if you want to perform overlay routing, then the only protocol that will be supported is OMP, and that has got some enhanced functionalities, routing functionalities. Now, how OMP works, how does it select best path, which all information it carries in its update messages and all that. So we have to understand OMP similar to like BGP, similar to EIGRP, similar to OSPF. So I have got a separate chapter for OMP protocol for overlay routing. So we will have to understand it very well.
What is this cloud on-ramp?
It's a cloud express feature.
I mean, what does it? I mean, what does it do? Why do we use this?
For cloud integration. So for cloud integration, the feature name is cloud on ramp. In Cisco SD-WAN, we call it what? Cloud on ramp feature.
So basically, if we have our network in any of the cloud,
so in Cisco SD-WAN, there is a feature called cloud on ramp feature that you can leverage for integrating your Cisco SD-WAN with cloud services, such as with infrastructure as service as well as with software as service. Make sense?
Which software? I mean, could you give an example of software as service?
I gave you Office 365, Dropbox, Box, Salesforce.
So we would be using that, I mean, for some application aware routing, or where would we use that?
I have because I told you, right? So this is just a description that we are going through. That's one point. Second, I gave you this example that since your internet connectivity is available now on the branch router locally, that is called local breakout. So if you want to have your SaaS-based application access directly from the internet from the local branch router, that is where you would require to integrate, or you would have to use this feature called cloud on RAM.
But if I have anything on cloud or internet, and I'm doing a local breakout, I can simply enable the local breakout. I mean, to access any cloud resource or any internet resource over the internet. Is that cloud readiness or cloud on RAM you're referring?
No. Okay. So let's say this is your SD-WAN topology, right? Where you have got couple of branches and you also have got data center, but also let's say there is a internet connectivity available in my branch offices, and there are two internet connections. Let's assume that this is not MPLS, this is also internet. So maybe this is from Airtel and this is from let's say, now you have got two internet connections in each branch, and now let's assume that we are accessing Office 365 or maybe Dropbox, maybe just Box. So those are the few examples of this software as service based applications. Those are SaaS based applications. Now, if you have got multiple internet connections, obviously you would like to access those SaaS based applications from the internet circuit, which is performing best at this point in time. If you simply go and add its static default route and do netting, then your router will be doing kind of load balancing, and then it will never monitor the link performances with traditional so-called routing that we used to perform. It will never monitor the performance of the link for accessing Office 365. But using a cloud on ramp service, what we can do, we can implement the DIA for SaaS-based applications like Office 365 or Dropbox or Box or for Salesforce, and that way your router will keep monitoring the performance with those SaaS servers, SaaS application servers using both of the internet circuits, and your router will be picking up the circuit which is performing best at the point at that time. That's cloud on RAM. That's one example. The other example is if you have a AWS or maybe a Azure, and you have your applications hosted there. So that's totally infrastructure as service, correct? Now you want to provide that application access to your branch users only, and those are private applications. You don't want to expose them over the internet. Would you be able to provide access to those applications now to your branch offices using internet only? Of course, no.
For that we will have to add
for that purpose, you would build maybe IPsec tunnel from your data center. Now, that
or
is
maybe
a single that will cause a single point of failure. That would cause a single point of failure, or maybe latency, lot of latency. That is a traditional way of doing it. In new way, you would have to build this IPsec tunnel now manually. But what if you have got 500 branches, 1000 branches? Would you do it manually across all 1000 branches then? Very difficult. Very difficult. And that is why this cloud on ramp for infrastructure service, that type of feature we have got. In that, what it does is, if your vManage is having the internet connectivity, what it does is, it creates a EC2, not EC2, but I would say VPC, a separate VPC that is called a transit VPC. Automatically, inside that, it will host EC2 instances as your routers, virtual routers. And then over the internet, now you would have a automatic IPsec tunnel established between your on-prem physical router and the virtual router inside transit VPC. And then you map your host VPCs where you have got your applications hosted. You map that host VPC with your transit VPC. And that way, now your lane users in your branches will be able to talk to those applications. But what you have done here is that you have created a transit VPC. You have hosted a couple of virtual servers, virtual routers there. And then you have built the overlay tunnels between physical routers in your physical branches and virtual routers that you hosted inside cloud. So this automation is called cloud on ramp for infrastructure as service. This is cloud on ramp services where you are automating all these tasks. Now again, I am not expecting any one of you to understand it fully. It just, I wanted to give you the list of features that, okay, these are the features. These are the kind of, benefits that we are going to get if we are implementing or we are migrating from traditional to the SD-WAN. These are the few advantages of Cisco SD-WAN over the traditional WAN. I hope that everybody understood it now.
Saurav, is it possible cloud on ramp practical possible in lab environment and zero touch?
No, it is not, sir.
Oh, okay.
So cloud on ramp with, cloud on ramp for infrastructure as service is not possible.
Yeah.
For that, you can use maybe you
Software
can
as a
use
service.
Cisco D Cloud.
Okay.
But Cloud Express or Cloud on ramp for SaaS, that is possible in our lab.
Okay. Thank you. And any documentation could you please provide us? So because that would be good for understands cloud.
Yeah, absolutely. I have already provided you all those documentation. Actually, if you look at your
Sure, definitely. Once I will familiar with the SD-WAN technology, then I will.
Yeah. So basically, if you look at your training portal, that has got everything there.
Okay.
Even the links to read about the cloud on ramp services for software as service as well as infrastructure as service.
Okay.
We have already provided all that information onto your training portals.
Yeah. And zero touch provisioning possible in lab environment?
No. It will also not be possible. I'll require to make few changes on my router, at least, allocating IP and all that. And then after we can see that how it goes.
Okay. Not an issue. Okay. Thank you.
But I'll be explaining that how it is working and what are prerequisites to perform zero touch provisioning.
Yeah, that would be great help from your end. Thank you.
This cloud side integration. So here it will be you are referring here the vWAN setup at the cloud side or
No.
the VNet in case of Azure one.
No, I mean,
none of that.
He was asking a different question.
No. I understand his question. My question is not the same one. My question is back to the cloud on ramp thing. So you mentioned that of course we have this solution where we can directly get the access from the branch to the cloud. So for example, in case of Azure cloud, so it would be a virtual router on the VNet hub, which will be created with this cloud on-ramp solution with the automated scripts or whatever it does, or some vWAN solution it will be using to get this working. Virtual WAN.
Yeah, I get it, but you don't have to ask this question at this point in time, since we are just going through the basics of all these things, So just to answer your question, but since you asked this question, because I'm not covering the technology, I'm just giving you a brief idea. And you're diving deep. Like when I talk about that, this kind of automation will be done by the vManage automatically. So obviously it is creating a script in background, and using that script, it will deploy like in terms of AWS, because in Azure, I am not really familiar with Azure terminologies. I'm much familiar with AWS terminologies, by the way. So in AWS, it will go ahead and create the VPC automatically, and that is called transit VPC. And also it will host those routers automatically. In that case, vManage must have the internet connectivity. And not only that, not only you should have internet connectivity available on vManage, but also you should have the valid credentials so that it can use to log in onto AWS portal. Because at the end of the day, vManage will have to log in onto your AWS portal. So you would require those credentials, valid credentials, so that your vManage can use them, can leverage them to create VPC and to create those EC2 instances. Make sense now?
Got it. Perfect. Thank you.
Yeah. So I'll talk about the SD-WAN architecture, by the way. And in this architecture now, we are going to talk about all these components that are participating in this Cisco SD-WAN architecture. So if you look at the overall components that would be participating in this SD-WAN architecture, then we have got vBond, we have got vManage, and then we have got vSmart controllers. So vSmart controllers falls under control plane, vManage falls under management plane, whereas vBond falls under orchestration plane. We also have got the vAnalytics, but as I told you, it is a SaaS-based kind of application provided by Cisco only for generating reports and all that. It doesn't do anything much. So even in my lab, I do not have the V analytics. And you would also see in production environment that many customers would not have this V analytics because it is not that much useful other than creating reports. So you can generate reports using V analytics, and that is why its name is V analytics, because it will provide you the analytical report. So it is not, I would say, compulsory component. It's not a mandatory component. It's not like without V analytics, SD-WAN won't work. SD-WAN can still be deployed. It would work perfectly fine even without having the V analytics in place. So that is something that you must always keep in your mind. So when it comes to control components, majorly we have to cover vManage, vSmart controllers, and the vMon. And in data plane, then we have got the WAN Edge routers. So we will also have to understand that which all WAN Edge routers are supporting the SD-WAN feature. Like initially, when SD-WAN was launched, we had a limited number of routers that had support to the SD-WAN feature. But nowadays, you would see that most of Cisco routers are supporting SD-WAN feature. And I'll go through that, right? I'll explain you that which all platforms are supporting the SD-WAN feature. But anyways, let's get back to the control components. So now I am going to cover each of those components, control components individually. And let's get started with vManage. That is also known as management plane. Now Cisco is calling it SD-WAN manager. So they have renamed it as a SD-WAN manager. It's a single pane of glass for day 0, day 1, and day 2 operations. You know what is day 0? Design. Day 1, implementation. Day 2, troubleshooting. So you can do everything from vManage. Not only you can create design, but also you can make configuration changes, and also you can do monitoring and troubleshooting. Even software upgrade can be performed from the vManage. So that is why we call it single pane of glass. Now remember, this vManage would require lot of hardware resources. Like the minimum hardware resources that a single vManage would require is 16 CPU cores, 32 GB of memory, right? And then it would require 500 GB storage and 20 GB storage for OS installation. That is a minimum requirement for installing one vManage. And remember one more thing, vManage is always going to be a virtual machine. So you cannot purchase a physical vManage from Cisco. Technically, that is not possible. So either you deploy it on top of ESXi, vSphere, or maybe you are using KVM, or you deploy it inside AWS or Azure. But to deploy one vManage, you would require that many hardware resources. And not only that, but also you would require 2 NIC cards, one for management and one for providing WAN connectivity to your vManage. That is the bare minimum requirement to deploy one vManage. Now, since it is...
So I have a question. So any license is required for the vManage to install in the cloud?
No, you don't.
Okay, means it's open source from Cisco?
It is not open source. It is Cisco proprietary vManage. You could call it open source only when you could use vManage to manage your routers from any vendor.
Sir, what is this EXI?
ESXi, it's a VMware virtualization. So either you will have to use the VMware virtualization.
Means we can just install this software in any system or this EXI.
No, I mean, not in any system, but there are servers like HP servers.
Yeah, that's the same server.
It's a hypervisor in short.
Okay.
So it can be installed on top of what? Hypervisor. So hypervisor could be ESXi, could be KVM, or maybe you would be installing it in your cloud. So it's up to you. Although I'll be doing this installation on top of my ESXi. I'll cover that how to deploy vManage on top of ESXi. Although in your labs, you would have it inside your EVE-NG, but for your knowledge, or I want you to get more knowledge. So for that purpose, I'll also deploy this vManage on top of the ESXi. So you get some exposure that how to perform the on-prem deployment. And my hypervisor that we have in our infrastructure is ESXi. We don't use KVM. We use only ESXi. That is from VMware. Now, considering the amount of hardware resources. If you have a small customer which has got, let's say, 10 sites, and for redundancy purpose, let's say you have to create multiple vManages. Do you think that a small customer would be able to bear that much cost? I mean, that's very difficult for them, right? For one vManage, if you require that much of hardware resources, and let's say you are creating a cluster of 3 vManages, so imagine that how much cost you would have to bear. It will become very expensive, too costlier, and therefore customers will never be moving from traditional WAN technologies to the SD-WAN then. And that's an issue. So Cisco fixed it by having this feature called multi-tenancy. What multi-tenancy does is that it allows as a MSP. Now, what is MSP? Managed Service Providers. Can you give me a couple of examples if you know some of MSPs? Who all are the MSPs around you that you see in the market as of today? Like Cisco itself is MSP, right? They also provide managed services to their customer. Then we have got HCL, we have got Orange, we have got AT&T, we have got British Telecom, we have got Accenture, we have got Capgemini, we have got Wipro, Infosys, etc., Tech Mahindra, and so and so. These all companies are managed service providers. Now, all these companies would have small customers, medium customers, and of course, large customers. So when they are deploying this SD-WAN solution, especially for the smaller customers, then this feature of multi-tenancy, where you can use a single vManage for multiple customers. So this multi-tenancy feature would allow you to leverage a single vManage for multiple customers. So basically what you would do is you would create a cluster of vManages, create it, and then use that cluster of vManage for multiple small customers. That's how you can reduce the cost for your small customers. So for that purpose, we have got this multi-tenancy. Does that make sense? Centralized provisioning. You do provision everything from vManage. Like if you are making any configurations, you're going to perform it from vManage only. All your policies, config templates will be creating from vManage. You would do troubleshooting, monitoring from vManage. That is why we call it single pane of glass. You perform software upgrades from vManage. You would have the GUI access, graphical user interface. So basically, we would get the GUI access of the vManage. We will always get the graphical user interface with RBAC, role-based access control. It is highly possible that in your organization, you have got a team of tier 1 engineers, a team of tier 2 engineers, a team of tier 3 engineers. And if that's the case, then you would not like them to have the same level of access. Maybe for tier 1 engineers, you would like to provide read-only access. For tier 2, read-only plus some of read-write access. Some of, not everything. For tier 3 engineers, probably read-write both. Like you would try to provide full access to your tier 3 engineers. So that is where this role-based access control comes into the picture. And we can do that, by the way. Like for different group of admin users, we can provide different level of access. And that is called role-based access control. Not only that, but also your vManage is going to support programmatic interfaces like REST and netconf so that you can perform automation. So using REST API, you can integrate vManage with third-party applications like ServiceNow. So if you have got ServiceNow in your organization, you can do that integration with vManage using REST API. As a result, now if any alarm is created on vManage, then a service ticket corresponding to that alarm will be created by ServiceNow and will be assigned to a distributed list of the team, of your team, tier 1 engineers, tier 2 engineers, or tier 3 engineers automatically. So that is where this REST API will come into the picture for third-party automation. As I told you, like I just gave you an example of ServiceNow. There are plenty examples. There are plenty third-party applications that you could integrate with your vManage. But I just gave you an example of the ServiceNow. In a way, so if an alarm was generated on vManage, then a service ticket should be created by ServiceNow and it should be assigned to your team automatically. Not only that, But also if that problem gets fixed automatically, then that service ticket should be updated by ServiceNow automatically. That problem is fixed, and so that your team will get to know that this problem is fixed now. So that type of integration is required. Make sense? And that would be achieved by the help of REST API. Remember, as part of this training, we are not covering automation. It's not an automation training. Although I'll show you that which all REST APIs are supported by vManage and how to leverage them. I can run, one or two APIs in front of you so that you get more familiarity around that. I gave you this example of integration for creating service ticket, but also you could perform this integration for automation. Like you have created a Python script for attaching and detaching the devices from the device templates. So again, you would have your Python script talking to your vManage using REST API. And by default, your vManage is going to use netconf to talk to other components by default. It does not use SNMP. And netconf is an advanced version of SNMP. So whenever vManage talks to your WAN Edge router, talks to vSmart, talks to vBond, it talks to them using netconf protocol. It does not use SNMP. Does it mean that Cisco SD-WAN does not support SNMP at all? I would say no, it's not like that. So for an example, if you are having a Kiwi or maybe not Kiwi, but let's assume any third-party monitoring system, any third-party monitoring tool is there. It could be Kiwi or something else. Now you want to get the data from routers. So can you, now that is supporting only SNMP. So is it possible for your routers to set up the SNMP server and SNMP community? Is it possible? I would say yes. We can still make that configuration on our router so that that third-party monitoring tool can still talk to my routers, and not only routers, but also to vManage, to vBond and vSmart. So SNMP is still there and we can implement it if required, if needed. So that's SNMP. Remember that netconf is an advanced version of the SNMP. Why? Because it is fully secure protocol and it runs on top of SSH, port number 22. And highly resilient. Why? Because its operating system is a Linux-based operating system. The kernel of the operating system is Linux-based. So the operating system of the vManage was developed on top of the Linux. That is something that you should always keep in your mind. And that is why we call it highly resilient. So I'll continue this further during next week now. We'll continue talking about the vManage first. We'll take your questions and we'll proceed further towards, like obviously we have got control plane, that is vSmart, then orchestration plane, and then we have got data plane, then we have got REST API, then we have got vAnalytics. So we will have to learn about all of those components. That we will do